Okay, we've got a worked example here for a coordinate geometry circle problem. This is a sort of typical A level, probably more AS level kind of problem. But it brings out a couple of useful things. Let's have a look. The circle C has radius 5 and touches the y-axis at the point 0,9, as shown in the diagram. Write down an equation for the circle. Okay, so I've labeled the center of the circle R. This is it here. I've drawn the straight lines in. So this is what we are given. And given that the circle touches the y-axis at this point here, we can deduce therefore the center of the circle, because the radius is 5, also given that the center of the circle is at -5, 9 with a radius of 9. Well, we've got everything we need there in order to actually write out the equation of the circle, and that equation is x minus the x coordinates of the center, which is -5, so it's x plus 5 plus squared plus y minus the y coordinate squared, and that's equal to the radius squared. So that's what we've got there. Right, so the second part, a line through the point P, which is 8 minus 7, is tangent to the circle C at the point T. Find the length of PT. Okay, so I've drawn that in there, and it's tangent to the circle. There, so of course, the being tangent, it's at right angles to the radius. So I think at this point, probably the bit of invention that's needed to solve this is to visualize this triangle here, this right triangle here. It often comes into these sort of things when you've got tangents and radiuses. May well be some right angle triangle involved, which will probably involve Pythagoras. Let's have a look. We're asked here for the length PT from the point up to the point where it touches the circle. Yeah, we don't know what this point is, this point T. But we do know, we know the endpoints of this, this hypotenuse, and we know the length of this. Now, if we know the endpoints of the hypotenuse, we can work out its length. Okay, so let's do that first. So the length of PR, well, if we can imagine, see this grey line here and this one here, what we're essentially doing is using Pythagoras on this. So this distance here, and the horizontal distance, if you like, is going to be 8 minus this coordinate, which is -5. So it's 8 minus -5, 13 in fact, squared. And then we do the same thing for the y coordinates. We get -7, then -9 squared, and we want the square root of all that, and that's going to come to the square root of 425 in actual fact, which is 5 root 17. Okay, so now the second bit that we need is the length of RT. We've got RT here, and that's a radius, so that's 5, so that's nice and easy. So by Pythagoras, on this black triangle here, we know PR squared is equal to PT squared plus RT squared. It's the hypotenuse is equal, square on the hypotenuse is equal to the sum of the squares of the two sides. Rearranging, we get PT equals the square root of PR squared minus RT squared. PR squared being 425, RT squared being 25, 5 squared. And we evaluate that, we get 20. So the length of PT, therefore, is 20. And we're done. Okay, so I think that's reasonably straightforward, but it does help to illustrate one or two useful things. And thank you for listening.